So we'll repeat some of the points here in terms of the theories and mechanisms. People have been looking at these for a long time. Various types of simplified barotropic and baroclinic models that produce Rossby waves based on the diabatic heating in the tropics and what happens to them have been looked at by various people like Webster, Zhang, Hoskins, Caroli, Chen, you can name. There are many papers. This is from Webster and Holton, for example. These figures I took from a nice review paper by Song Gang and his group, for example. He's also worked a lot on this, Tim Lee and so on. So this is the 300 hectopascal perturbation kinetic energy distribution for January and February of 1971. The stippled areas enclosed by the heavy dashed line denote the regions of mean easterly winds. Okay, so you have the westerly duct here. So you are looking at the African continent into the eastern Indian Ocean and maritime continent here. East of the dateline towards the South American continent and back to the Atlantic sector here for January and February, so very much sub-seasonal time scale, although these are for a particular year. So we talked already about the role of the westerly ducts, and if you want, you can do more homework on the Rossby waves and understand why Rossby waves can work well in terms of sending their energy flux, Rossby wave activity flux down into the tropics in these westerly ducts and tropical upper tropospheric troughs. So the zonal shear matters, meridional shear matters in terms of interactions of the Rossby waves with the background flow, and the vertical shear matters as well. So Rossby waves get stretched and compressed. The wave number can change. So in a Doppler shift sense, they can move eastward in the mid-latitudes that we looked at, that are in the storm track, constantly breaking and producing streaks of PV substance into the tropics through these westerly duct and tropical upper tropospheric trough, depending on the season. And we are talking about background state that depends on El Nino and La Nina, as we said, and the MJO source is moving, as well as there are other sources like the Asian, South Asian, East Asian, and West North Pacific monsoon. So all are heat sources, MJO being the moving one, and the location of the MJO heating is found to be very sensitive. So obviously it's going through different zonal background states as well, and the Rossby wave meridional turning latitude depends on the zonal shear, meridional shear as well. So the Rossby wave can go from a long wave with low zonal wave number to a short wave with increasing wave numbers, which can result in energy accumulation at certain longitudes, and similar things in the meridional direction. Vertical wave numbers can change based on vertical background state as well, and in fact the vertical shear in the tropics associated with various monsoonal forcing and MJO forcing are considered critical for producing propagating features and energy fluxes, which we in fact talked about in the case of meso, for example, where the vertical shear is giving us a horizontal baroclinic vorticity, which then generates vertical, which is interacting with the background vertical velocity associated with the convection and frictional convergence and instability that can make it propagate forward because of the background humidity profile and so on and so forth. So same processes are involved here as well. So here you can see the distribution of the turning latitude of an equatorially trapped Rossby wave in the two-dimensional basic boreal winter 200 hectopascal zonal flow. So typically when we look at the Rossby wave interactions, we always do simplified models with constant background zone, stationary background state, constant shear, constant zonal velocity, and so on. So I have a series of lectures on those based on Peter Webster's book in the course on tropical dynamics that you can look up. So here, turning latitude is basically where the Rossby wave energy doesn't go past that latitude and can decay quickly exponentially beyond that. So you have spots X and Y. So if there is a extratropical forcing located here, where the location is beyond the turning latitude of the Rossby wave, then the forcing will not significantly affect the equatorially trapped waves, whereas if here you can see that the turning latitude is much further extended meridionally because of this westerly duct. Again, we are going through this without fully explaining the Rossby wave dynamics, which you must read up if you want to get deeper into this. But here you are within the turning latitude, in which case the forcing located here in the extratropics is going to strongly affect the trapped waves. It will strongly force trapped waves. Okay, so here no waves will be generated. Here waves will be generated. Okay. The other idea is to also look at these things where schematic diagrams showing the impact of different basic states on the locations of the emanations to higher latitudes. The two panels are similar to the situation for La Nina and El Nino. The broad arrows indicate regions of transient accumulation along the equator and transient emanation to higher latitudes. The shaded regions refer to equatorial easterlies. So we already talked about the equatorial easterlies here and here with the westerly duct here. So you can see obviously where the energy flux can go out depends on those critical longitudes, and the accumulation and transient accumulation and transient emanations are again related to this Rossby wave stretching and the changes in wave speeds and wave numbers, and energy accumulates if the waves get shorter and shorter and cannot propagate out because the wave speed decreases as wave number goes up, and then the energy can get released into fluxes that can emanate to the extratropics from the tropics. Okay, so those are the critical regions. We have repeated a few of these points, but it's critical to remember how the low frequency variability, the climatological state, and the MJO moving heat source and the monsoon steady heat sources are producing these tropical extratropical interactions, in this case tropical forcing of the extratropics. These are the mechanisms which have been looked at with various types of models, with observations, and we will then look at the extratropical forcing of the tropics in terms of what theories exist and what observations say about them in terms of mechanisms. Okay, so these two podcasts are specifically on mechanisms of tropical extratropical interactions at intraseasonal timescales.